Alrighty, dilations. Okay, so dilations change the size, but not the shape. So similar to how similarity is, similar has same shape, different size, but it stays proportional. Dilation is also going to stay proportional. So is it isometric? No, this is the only one that's not isometry. The scale factor determines the size, how big or how small it gets. Enlargement is bigger. Reduction is smaller. And it's similar. Okay, so if the dilated image is larger, then the scale factor is greater than 1. This is an enlargement. And if it's less than 1, which would be a fraction, and our scale factor, we're going to use the letter K, which is below. So this would mean K is greater than 1, K is less than 1, and that's a reduction. And we use the letter K for our scale factor. All right. The scale factor has the new size over the old size. So number 1 is an enlargement. Oh. So we're saying this is the image, so it's going to be the other way around. So our image is shaded. Our pre-image, so it's a reduction because the new shape has a size of 2 from a fixed point. The old one had a length of 3, so I'm like looking at these two lengths right here, the length from a fixed point, and so the scale factor K is equal to 2/3, which is less than 1, so it is a reduction. All right, this one has the prime symbol on this one. So that's the image. This one is the pre-image. This one is a enlargement. And the way we can do an enlargement is you can pick any side and then do the corresponding sides as your fraction. So I'm going to take this one because this one's easy to see that it's 1, 2, 3. The original is 2. So the new one is 3 units. The old one was 2 units. So K is equal to 3/2, which is more than 1, which is an enlargement. All right. Okay, so we can tell which one is the enlargement because of it's got the little primes by it. So this one is the image. This is the pre-image. So it is an enlargement because it got bigger. And the scale factor is going to be, we're going to take this side length and this side length. So the new one is 3x. The old one is x. I can cancel out my x's So my scale factor K is 3. So it's 3 times as big, 3 times bigger. Okay, so now I have a triangle. So that point stayed the same. So the green one, same, is the image. And it has the little prime. This one is the pre-image. See if I can write it really tiny in here. Okay, and so you need to be careful because, well, first of all, it's an enlargement. The scale factor is going to be the new length, which is not 4. Remember, the new length is this whole thing right here. Let's see if it's weird that I can do it in green. So it's really 8 plus 4. So the new length of this one side is 12. The old length is 8. So we're going to divide by 4, and that's going to be 3 over 2, which is greater than 1, which means it's an enlargement. So it all worked out. Okay, then there's another kind of dilations we do where we're focusing on the distance that the image and the pre-image are from the origin. So the distance we're using is going to be this distance for the pre-image. And then this distance for the image. And if you notice, if the scale factor is centered at the origin, then you can use the following rule. You can take the scale factor, the new point is the scale factor times x, the scale factor times y. So if we're centered at the origin, the scale factor is 2, so that means k equals 2. Then that means our new point is going to be 2 times negative 1 and 2 times negative 2. So it's going to be twice as far away, which makes sense. Okay, the next one, still centered at the origin, k equals 1/4. So we're multiplying 4 times 1/4 and 12 times 1/4, which is the same as dividing by 4. Okay, so centered at the origin. So my scale factor is 1/2, so that means it's getting smaller. So instead of going 1, 2, 3, wait, where's my, oh, here it is. I was like, where's mine? Okay, so we have 1, 2, 1, 2, 3, 4. So A is at 2, 4. So half as far away is going to be 1, 2. That's going to be my A prime. Because I took 1/2 of 2 and 1/2 of 4. Okay, point B is at 6, 2. So my reduction is going to be at 3, 1. So that's going to be my B prime. And then C is at 10, 6. Which means C prime is going to be at 5, 3. C prime. So it makes it easier if you have the points, because then you don't need to know the distance of the lines, because if it's not going horizontal or vertical, it's hard to count. So there you go. Okay, so centered at the origin, scale factor of -2. Ooh, what's going to happen with -2? Is it going to be bigger or smaller? K is equal to -2. I think it's going to be bigger, but it's going to be down in quadrant 3. Let's see what happens. Okay, so K is at 0, 2. So K prime is going to be at 0, -4. Because 0 times -2 is 0. 2 times -2 is -4. So here's K prime. I is at 1, 3. So it's going to be at -2, -6. So it's going to be right here. T is currently at 2, 2. So it's going to be at -4, -4. And E is at 1, -1. So it's going to be at -2, +2. And that is E prime. So what happens when it's negative? It flips over. The image flips. I need to be careful with what I say here. Like a rotation, kind of. And because K, you almost have to say that it's the absolute value. K is greater than 1. It's bigger, it's an enlargement. So really we're talking about the absolute value of K. Because the negative changes the direction that it gets bigger. But it doesn't mean it's a smaller number.